Okay, Olivia, this is section 10.4, I believe. 10.4, inscribed angles. Did you guys get the homework assignment written down? This guy right here, 597. Okay, now, if you look at this homework assignment, check this out. I did 2 through 10 evens on the front side, but then here's my madness that I have going on here for the back side. The back side, I just had you do the right column. I was going to have you do evens on the back side, but look at the evens. 14 and 16 and 18 and 20. And in order to do those, you have to solve the one right above it also. So you would end up having to do just like all of the problems. That's why I chose just the right column. Okay, so there is a method to my madness. That's why all of that was there. Okay, good? Yes? Okay, couple of concepts here. I like this section. This is one of my favorites. These are inscribed angles. All right, off to the side over here. Check this out. Stop. Stop. I'm talking to Remington. Okay, here you go. Off to the side over here, I'm going to draw something. And let's say we have, here's my center. Let's say I have this thing going on here. And this is, let me make it bigger. This is 100 degrees. Okay? This guy in the center is called a central angle. Yes? Yes. Central angle. All right. If I would ask you what the measure of this arc is, not the length, not inches or centimeters, whatever, what's the measure of that arc? 100 degrees. True? All right. Now, think of this pink little guy as a bow and arrow, right? And this is the string that you pull back. We're pulling it back to the center. That's 100 degrees. This is 100 degrees. But let's say I take those same spots right here, and instead I pull the string all the way back to the edge of the circle. This is called an inscribed, right? This is called an inscribed angle. Okay, this is a central angle because it's in the center. Central angle versus inscribed angle, okay? Now, this is 100 degrees right here, right? He looks bigger than 90. He's slightly bigger than 90. Do you agree that that's slightly bigger than 90? Like bigger than a right angle? What about this guy? 100 degrees also? How do I figure out what the measure of this angle is?
Radius. It has probably something with the radius.
It's easier than that. 50. How many degrees do you think that is?
Yes, 20.
45.
No.
50.
50.
Oh,
Why
so
50?
half.
You literally just slice it in half.
That's what I said.
Whatever the arc is, if you pull it back to the center, that's the same angle. But if you pull it all the way across, it's going to be half. Okay, now, ready? Let's say instead, I take these two guys and I pull it back over here. What if I pull my string like at an angle, like I pull my string up
It's
instead of,
half.
is it still going to be 50?
Yeah.
You betcha. Let's say I pull my string down over here.
Still.
50.
Still 50. No matter where I pull it at, as long as I pull it to the outside edge of the circle, no matter what, if I pull it back, it's going to be half of what it was before. That's an inscribed angle. It's all the way across the circle. That's where I'm pulling my string back to. Got it? Okay. All right. Now, also, here are 3 different cases of what we got going on here. It does not matter. If this is my arc and my arc here, let's say, is 120. It doesn't matter if I'm pulling it back and the line is going through the diameter. Do you see that this is the diameter? Yep. Doesn't matter. This angle is going to be how much? 60. Okay, this one, I have taken this arc, which let's say is 160, and I've pulled it back where the center of the circle is inside of that arc. What's this angle going to be? Doesn't matter. Still 80, right? This one is a really little tiny slice of pizza. And if this is, let's say, 80 degrees, the center of the circle is not inside of my angle. What's this angle going to be? Doesn't matter. It's still 40, right? It does not matter where the center of the circle is in relationship to your angle when you pull it back. As long as this is touching the edge of the circle, it's going to be half of what the arc is. Got it? If you pull it back to the center, like if I was just pulling it back this direction, how much would this angle be? If I'm only pulling it back, how big would this angle be?
120. No.
160. He would be the same as the arc, right? Arc is 160. If I pull him back there, that's 160 also. But if I pull him all the way across, he's 80. Got it? Okay. All right. Let's go to example. Oh, right here. Down at the very bottom. Look at this diagram right here. Whoop. Okay. Look at these as like slices of pizza. Okay. So let's say DA. This is the arc that I'm looking at. That's like your pizza crust, right? And here is an inscribed angle, angle C. Yeah? Okay. That's a slice of pizza, right? Okay. But if I look at angle B, he has the same pizza crust as angle C does. So what's the relationship between B and C? They will be the same angle measure because they are the same pizza crust, just pulled back. Yeah? Does that make sense? B and C will be the same angle measure. All right, let's do example 1. All right, find the measure of each. The measure of arc CF. Do you understand that that's arc CF? CF with an arc over top of it. So I'm trying to find arc CF. Here's where I start. CF is asking for the pizza crust. All right, here's how I do this. The pizza crust is that guy. I'm going to trace the sides of my pizza back. That's the sides of my pizza. 40 degrees is in here. That's where the 40 degrees is pointing to. So what is CF going to be? 80 degrees. You double it. Yeah? Equals 80. So angle C is asking for, I'm going to erase. Part B is asking for angle C. So angle C is this guy right here. And I'm going to trace the sides of my pizza. And the pizza crust that they're looking at is this one. Okay? All right. What's angle C going to be? 49 degrees. The crust is 98. You pull it back, it's half of that, which is 49 degrees. You see that? Okay, the 40 was this angle right here. Okay, so 49 degrees. Do you see how this works? Yeah. All right, example 2. We've got lots of stuff going on. They want to know what the measure of angle A is. All right, so let's just start with angle A. Angle A is this guy right here, which is 5x minus 12, but I need to figure out what that is exactly. So I'm going to trace my pizza. Whoop. And BC is the crust of my pizza, right? I want to know angle A. Okay, but what do we know about angle A? It's the same as angle D because they share a pizza crust, yeah? Okay, so angle D and angle A are going to be the same. I'm going to set those equal to each other. 5x minus 12 equals 3x plus 2. And subtract the 3x. I'm going to add the 12. So I've got 2x equals 14 and x is 7. But I'm not done because I want to know angle A. So I'm going to plug 7 into here. What's 5 times 7? 35 minus 12. 23 degrees. Yeah? Perfect. What's up? You need me?
Yeah, just real quick.
Okay.
This is on here with these.
Oh.
She could like, so we peeled off the metal part,
Uh-huh.
but I don't know if it's like this stuff underneath of the wood thing. So she was wondering if she could like put stuff on them,
Okay. What is she wanting put on it?
like laser engraver kind of thing.
Yeah, she wants it engraved.
Yeah.
We
There's
could
some glue on it.
we could sand them down and restain them. They might look a little bit different, but we can play with that. And then yeah, we can laser engrave it.
Okay.
Totally fine. Yep. Just tell us what you want, or we could take, I don't know, depending on what she wants on them, we could vinyl them. Like just take permanent vinyl and stick them on there. Whatever. Laser engrave would look better, but yeah. Okay. All right. Good on that one. Example 2. Skip example 3. It's a proof. We don't like them. Go to example, no, don't go to example 4. 2 things. Before example 4, are you guys on this page? 595. Yeah, go to 595. 2 things. Ready? All right, take a look at this. They are putting a triangle inside of a circle. Then the next shape, they're putting a quadrilateral, not a square necessarily, but a quadrilateral inside of a circle. So let's talk about triangles first. Ready? Here is the deal. This is very, very important. When the third side of your triangle is the diameter. Do you see that that's a diameter? Right? When your third side of your triangle is the diameter, they make this go on here. Angle G is a special angle. Let's talk about what happens to him. If that is the diameter, let's talk about this arc. Here's my pizza crust and here's my pizza. Okay? All right? Pizza crust, pizza. How big is this arc right here? How big is that pizza crust? 180 degrees. It's half of the circle, right? If that's the diameter. If I pull it back, what's angle G going to be? 90. So the deal here is that if they slap a triangle inside of my circle and one of the sides of the triangle is the diameter, this angle will always be 90 because half of the circle pulled back is 90. Do you see how that works? Okay? They're going to do that a ton on your homework assignment. Like, I don't know. Where are they? On the backside, hey, on the backside, look at this. Ready? This is a diameter. Pull it back. Angle Y is going to be 90 degrees. This guy's a diameter. Pull it back. This guy is 90 degrees. Let me show you how this works. Let me go back up. I'm making you dizzy. Whoop. Okay. Here's my circle. Here is my diameter. You don't have to draw this if you don't want to, right? Here's my diameter. Got it? I could make a triangle look like this, right? This is going to be 90 degrees. I can make my triangle look like this. This is going to be 90 degrees. I can make my triangle look like this. This is going to be 90 degrees. Do you see how that works? No matter what, if this third side is the diameter and I pull it back, those are all going to be 90 degrees. Doesn't matter where I put it at. Make sense? Okay. All right. The next one is any quadrilateral. Okay? Not a parallelogram. Can you get a parallelogram to fit inside of a circle?
Yes.
I don't think so. Because if I try to do this, my circle is going to go like this. That's not going to work, right? I cannot get a parallelogram to fit inside of a circle, right? So where like they all touch, right? In a parallelogram, the rule was consecutive sides did what? Or consecutive angles, I should say. What was true about consecutive angles in a parallelogram? They add up to be 180, right? They add up to be 180. In quadrilaterals that are inside of a circle, the rule is the opposite ones add up to be 180. That's how it works. Opposite ones add up to be 180. Yeah? Does that make sense? Okay? Okay. Yeah. Yeah. I could show you why that is, but I'm not going to bore you with that. Okay, 180. Opposite ones add up to be 180. They're not the same. Like angle M is not necessarily the same measure as angle K, but these two are going to add up to be 180. So if angle M is 100 degrees, angle K is 80 degrees, right? And so on and so forth. That's how that works, okay? Let's go to example 4. They want us to find the measure of angle K. Angle K is this guy right here. Is angle K the same as the measure of angle M? No. All right, what's some things that we know?
L is 90.
L has to be 90, true? Because this is the diameter. All right, so if that's 90, what do all three angles add up to be? 180. So what does M and K add up to be? 90, right? Okay, so 5x minus 4 plus 8x minus 10. 5x minus 4 plus 8x minus 10 is equal to 90, and then we solve for x. Okay, now 5x and 8x are on the same side of the equal sign, so that makes 13x minus 14 equals 90. All right, let's add the 14 over. 13x equals 104. And divide by 13. What? Is it 8? I think maybe it is. Somebody check that, though.
Yeah,
8?
There's 80 and then 24.
80 and 24. Yep, you're right. 8? But they want the measure of angle K. So I'm going to plug 8 back in here for K. 5 times 8 is 40 minus 4. 36 degrees. Yeah? Do not set angle K and angle M equal to each other. They're not equal. They add up to be 90. Got it? Next. Was that too fast? Are we doing okay? Last one. Example 5 on the backside. Example 5 on the backside. Luca is creating a collection of stained glass ornaments. The ornament shown uses a quadrilateral inscribed in a circle. That word inscribed means it's like touching all of the edges of the circle, right? And what they're talking about here is the yellow object. Okay, so this is my quadrilateral. Kind of looks almost like a trapezoid, but I don't think it is. Right? This side I don't think is necessarily parallel to that one. Okay, so they want us to find the measure of angles F and G. Great. What do we know about a quadrilateral inscribed inside of here?
All 180.
What?
It's all 180.
What's all 180?
E and G.
E and G add up to be 180. Okay, so let's add them up. These two add together to be 180. Can we add some stuff in our head? What's 3x minus 6 plus x minus 4?
4x minus 20.
4x minus 20. That equals 180. Do you see what we just did in our head? Added those two in our head. Was that confusing? Okay. Add the 20 over. 4x equals 200. And if you divide, x is 50. Okay. Let's find y now. Real quick before we do anything else. Okay. What about D and F? Are they the same as each other?
8y.
D looks bigger than F.
8y
Add
plus
up to.
They add up to be 180, no matter what. The opposites are add up to be 180. So 5y plus 16 and 3y plus 4. What's that?
8y plus
8y plus 20 equals 180. Okay. Am I going too fast? Minus 20. 8y equals 160. And divide by 8, and y is 20. Okay. Next, we have to find D and F, yeah? Angle, right? F and G.
You just plug in numbers.
Yep, we plug in numbers. So if I'm looking for angle F, I want 3y, and y we said was 20, plus 4. What's angle F going to be? 64 degrees is angle F. F equals 64 degrees. G is x minus 4, and x is 50, so 50 minus 4 is G, and G is 46, right? Very good. Degrees. Questions about that? All right, so a couple different concepts going on in there. Beautiful, there's homework. Okay, good? Beautiful? Great.
Stop saying